Yeah.
Law of science. Write down what it is. Hopefully you remember. If you don't remember, that's okay. But law of science is the shorter of the long solving. Go for it.
Sine of A over 8.
Write it down. Write down what you remember about it. Hopefully you remember something. If you don't remember it, okay. Remember it quick. Or you could do what Ethan's doing and Avi are doing it. Making use of your resources. Your brain is the best resource there is, and your calculator. What?
Good one.
All right, what do we got? Law of sines. There's lots of versions. Just give me one, and we'll figure it all out. Sine of alpha over A. Keep going. Sine beta over B. Keep going.
Plus sine C over.
All right, there are numerous versions, and we'll talk about that in a minute. Angle A. So technically, this is why we use alpha, beta, whatever. The measure of angle A. So people will just say, oh, A is this, but technically it's a measure. So you should be putting in that whole angle thing. The measure of angle B is known as beta. And the measure of angle C, we did last year, I think.
Gamma.
Gamma. Okay, I can't make very good gammas. It looks like a kind of a Y with a thing. I don't draw very good Greek letters. Alpha, beta, gamma, delta,
Epsilon.
epsilon, which you're going to learn,
Theta.
theta, pi. What else do you know?
Phi. 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 Is it phi or phi? It's phi. Phi.
Phi.
Phi. What?
What other ones do you know? Alpha, beta,
Zeta.
gamma, delta, epsilon,
There's one
beta.
Iota, kappa, lambda, mu, psi, omicron, psi, negative.
What's the omega 2?
Omega, like also, but it's a song that we learned in 6th grade.
You learned
I
the
just
song in
remember.
6th grade?
Wait, say it again.
Yeah.
Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, psi, omicron, pi, rho, sigma, tau, upsilon, phi, chi, psi, omega, beta.
Oops.
You join a sorority or fraternity, you'll learn it right away. All right. You know, these are really important things to know. But you know what? If you're going to do anything in science or mathematics, Greek is everywhere. Okay, so let's go back to geometry for a minute. We're going to do 3 or 4 things in geometry. The proportionality, equivalency statements. A over B equals C over D. Right? Proportion. Give me some equivalent statements to A over B equals C over D. There are 3 more. Yeah, sorry. Okay. Yes. Don't use that word, but can you give me proportions? Yes, that is true. AD does equal BC, but that's not a
Oh, you want like B over C equals B over
There's not a proportion. Ethan,
B over A equals D over C.
the reciprocal. B over A equals D over C. Is that what you said?
Yeah.
Oh, sorry. That's what Soren said. My apologies. It's Friday. That's our excuse. Okay, there's two more. There's two more equivalent proportions. It's going to be super helpful when we're solving and you're trying to like manipulate the calculator. You can manipulate the proportions. The keystrokes on the calculator become a little bit easier. No? No? A over C equals B over D. And then the reciprocal of that, yeah. Did I do that right? Yeah. Okay, so that's one geometry thing we're going to review. And then the other geometry thing, which I should have started with, oh well. There are four congruencies, or four congruency statements. Now, what am I looking for? Four ways to prove triangle congruency. Five ways to prove triangle congruency. List them. You should know them. You should know them. You should know them. You should know them. If you had me last year, you should know it for sure. 5 ways to prove triangle congruency.
ASA, SA, SSA. Oh, we got SSA.
Good, Amanda.
ASS
Correct.
is ambiguous.
Exactly.
That was in the homework.
What homework?
Oh,
yeah.
Wait, homework.
What?
SAS and SSS.
You didn't have homework.
We did. We did have a little while ago. We had some.
What are you talking about? There was homework that was due on Tuesday on section 8.1.
Yeah.
SOHCAHTOA, Pythagorean theorem, right triangle trig.
And this.
8.2, I just assigned that this morning. It just popped up on classroom 10 minutes ago.
It included an ASS. Like we had to give 2 versions that would work for.
Oh, what? We never turned in.
Yeah.
All right, give me one of the 5 ways.
SAS, right?
SAS, side angle, side. Give me another one. Side, side, side. Give me another one.
SSA.
No, not SSA. Not SSA. SSA is ass backwards. You cannot. That's what it is, though. That's how you know it's not good.
No, wait, but continue the ambiguous. No, it's not ambiguous.
Not. You cannot. Time says that. You can solve a triangle with the ambiguous case. You cannot prove congruency. I'm talking about
Yeah, that's
congruency.
too long, though.
It was last year.
Yeah.
Hypotenuse leg. I love it. There's 2 more.
No.
ASA and angle, angle, side. There's no such thing as angle, angle, angle. Wow.
Oh.
Congruency. We're not talking about solving. We're talking about congruency. SSA, ASS is not a way to prove congruency. You can solve a triangle. You cannot prove congruency. And we'll talk about that tomorrow. No, Monday. Not tomorrow. Okay, so let's take a look at hypotenuse leg. What kind of triangle has a hypotenuse? A right triangle, and only a right triangle. No other triangle has a hypotenuse. It has to be a right triangle. So if I want to solve, for example, if I give you, you either have to be told it's a right triangle or it has to have the right angle symbol. No assumptions. So if I tell you that this angle is 43 degrees and this side is 10, can you solve the triangle? Yes. How are you going to solve the triangle? You're going to solve it using the overall method is true. So it is true. So good job. Okay, so we're going to do the congruency statements in conjunction with the law of sines. Bless you. Yeah,
Wait, so if you solve the triangle though, can't you prove this?
yeah, using hypotenuse leg.
Oh.
When we do ambiguous on Monday, you know what? We'll just do it all today. So instead of, we'll just do the whole ambiguous, all of it today. All right, so angle, side angle, and angle, angle, side. If you know two angles, you automatically, you know the third. If you know two angles of a triangle, you automatically know the third, 180 minus the angles, whatever, etc. So let's just look at, I'm just going to look at this first proportion. It's true for all of them. If I know two angles, can I find the sine of each one of those angles?
Yes.
If I know that the angle is 32 degrees, I can find its sine on my calculator. If I know that the angle is 79 degrees, I can find its sine on my calculator. Agreed? So I know there are four unknowns, two angles and two sides. There are four unknowns in that proportion. Agreed? Okay, well if I know two angles, now there's only two unknowns. And an angle, side, angle, and angle, angle, side, don't I also know a side? Know a side? Yeah, so now I know three of the four unknowns. So for angle, side angle, and angle, angle, side, we use law of sines to solve both of these. Okay, before I forget, take out your calculator. You got to make sure you're in degrees, not radians. But you're going to need your calculator to solve this. So if you forget your calculator, no good. Make sure you're in degrees. And you can solve all this on your scientific if you want. Degrees, degrees, degrees. Mode. Chances are you're in radians.
No, we said degrees.
Oh, we are in degrees already? Fantastic. Doesn't have to check. What's wrong? What's going on?
Just act your calculators. Forgot for a second.
I couldn't use that calculator you gave me. It's so complicated. All right, I am the world's worst drawer of triangles, so just accept that about me now. All of my triangles look obtuse. All of them look obtuse, except for the right angles, are the right triangles. And I always use ABC because I'm boring. All right, so I'm just going to whip through an example. Okay, so you'll forget, and I will remind you, when I ask you to solve a triangle, that means all angles, all side lengths. Solving a triangle means find the measure of all three angles and the length of all three sides. And we will generically just do the 10. If I don't tell you, just generally use the 10. All right, measure of angle A, alpha. How do you find the measure of angle A?
180 minus 70 minus 33.
Okay. It's, 110 minus 33. 77? 87?
77.
Okay, so more little Is it 70? Oh yeah, 77 flat out. Bless you. No degree symbol, you're gonna lose credit. You don't have to have degrees in your work. I recommend it. That way, you'll just get in it's a good habit to get into. But if you forget the degree symbol, you're gonna lose a half a point. Every answer, you're gonna lose half a point. So that's like a potential 1.5 points per problem. Don't forget your degree symbol. Yes, Carolyn.
If we're solving for Enablement, is that way do you want us to show out like?
No, I'm just showing it for notes purposes. I would hope that you can just plug in and give me the answer. I'm just showing it for notes. Okay, do you want to find side C or side A next? Who cares?
Side A.
See?
Side A, I heard side A first. Lowercase. Is it wrong to put uppercase? No, but it's just not good notation. Get used to lowercase for sides and uppercase for Greek for angles. All right, help me out. How do I start it?
Sine 70 degrees over 11 equals sine 77 degrees over A. No.
I'm sorry, what am I doing wrong?
We're doing A.
Side
We're doing A, which means that this should be.
No, we're
77
on
over
A.
A.
C.
Oh, I chose to do C first. Sorry. I wrote A and then I did C. I mixed up the variables. Absolutely. I can see why you would be confused. 70 over 11 is equal to. Better? Do not round until the very end. Leave the values in your calculator. Do not round 10th until the very end of the problem. Compare with your neighbor, see what you got going on. I got 11.4.
Yep.
Be careful. If you get the 77 degrees incorrect, then your side A is automatically going to be incorrect. So while it's easy to find alpha, you're going to whip through it. But if it's not 77, then A is not going to be 11.4, etc. Find C.
Should we write like units, like 11.4 units?
Yeah. Yes, Sophie.
So like on the test conversion stuff, we write our final
What's that squiggly mean?
like the test.
Approximately. No. Sophie asked if we have to put the squiggly thingy, which is approximately. When we're doing word problems, it's much more important. So I just do it for notes purposes. Should you? Yes. Are you going to lose points for it? No. What's C? Nearest 10th. 6.4? Yeah? See lots of yes? Okay.
Yeah.
Okay, so when you're doing problems like this, two options for your final answer. You label the triangle. You said 6.4? Okay, so this is your answer, written all in the triangle, or off to the side, you write alpha 77 degrees. A, 11.4. Okay, either one of the two. How can you check a quick check to see if your answer is reasonable? How can you do a quick check to see if your answer is reasonable?
Look at the angles.
Yeah, largest angle associated with longest side, smallest angle associated with shortest side, and then the in between, the medium angle with the medium side. So let's check. The largest angle is 77 degrees, and it is associated with our longest side, 1124. Our smallest angle is 33 degrees, and it's associated with the shortest side, 6.4, and then the in between. So does that mean you got it right? No, but it's a good check. It's a really good check. Yes? Do I need to go through like 6 more? All right, let's talk about ambiguous. This is why you cannot use the ask case to prove triangle congruency. Okay, so the side-side angle case, and as soon as you get this, I would put a big star next to it. It's called the ambiguous case. What's that mean, ambiguous? What's it mean to be ambiguous? Unknown, unclear. First in the unit circle, last year, I guess. We said 30 degrees was associated with 1/2. Agree? Where else is the sign 1/2? Where else is the sign 1/2? 150. Quadrant 2, 150 degrees. For a total of 150. Agreed? Does a 150 degree angle fit inside of a triangle?
Yes.
When you do the inverse sign of 1/2 on your calculator, how many answers does the calculator give you?
One.
It gives you 1 answer. But in terms of a triangle, how many answers are there? 2. Okay, so let's say that I give you the sign, I'm going to just make up some random number, and I'm going to say that the sine of some angle theta is 0.793. That's it. Figure it out. What's theta? You need your calculator unless you're some like programmer in your head. Tenth, please. What's your calculator say? 52.5? Inverse sine, 52.5, agreed? Yeah? That's not it. There is another place where the sign is 0.793. There's another place where the sign is 0.793. And if you can figure out this part right here, you're good to go. Where else is the sign 0.793? So now? 180 minus theta. Sorry. The calculator's not going to spit out 16 answers. Besides the fact that you're doing an inverse sign on the calculator. So there's only one place with the inverse sign. Right? Inverse sign looks like such. Let's measure that angle altogether. Let's measure the whole angle. 127.5. Does 127.5 degree angle fit in a triangle?
Yes.
Sure does. It's less than 180. So when you're solving a triangle and you're given the ambiguous case, how do you know if the answer is 52.5 or if the answer is 127.5? So let's take a look. It could result in one triangle, no triangle, or two triangles. Hence ambiguous. Okay. Okay. 2, 3, and 4. You know an angle and you know two sides. You know an angle and two sides. You know 3 of the 4 pieces of information to solve the triangle. So where do you have to start? Where's your first setup? What's the first ratio?
2.
What's that, Kavi? Go ahead, what is it?
2 over sine of 4.
Okay, so Kavi is choosing to do the reciprocal. 100% acceptable.
Oh, wait. Never mind. Let's do sine 40.
You want to do sine 40 over 2? Okay. You know this whole ratio. You can get a value for that in your calculator. You can get a value for this in your calculator. So sine of the angle over length of the side. What other side do I know?
3.
Which is side
C.
C. So this is going to be the side of C.
Over 3.
So I get, I'm doing an in-between step, I get that the sine of C is 0.96418141445. Agreed?
Yes.
Okay. I'm going to leave the value in my calculator. I'm just going to write the shortened version on the board. So 0.96. I'll leave 0.3. It's almost 90-degree angle. This is almost 1. Sine of what angle is 1? 90 degrees. So this is almost a 90-degree angle. So you do the inverse on your calculator, and your calculator says the measure of the angle is someone close to
74.6.
74.6? Okay, so I'm going to draw it out like I did over there. I'm sorry, what was it, Catherine?
74.6.
It's not just 74.6. It's also
105.4.
105.4. There's at least one triangle because the measure of the angle is 74.6. So I'm just going to draw this out with the information that we just got. So I would just find C is 7.
Should the 105 be on the line?
What's going on?
The blue line, should that be?
Yeah, yes. What is it, 105.4? And this should be 74.6, yes. I had it labeled incorrectly. And then B is 40, B is 2, and C is 7. We just found out it was 74.6 on the calculator. 74.6, 40 degrees. I can find out what alpha is, agreed? Super careful. If your 74.6 is wrong, your alpha is going to be wrong. If your 74.6 is wrong, your alpha is going to be wrong. 74.6 should be in your calculator. That whole thing should be in your calculator. 180 minus 40 minus that number, then round. You might want to do some storing. Actually, you're definitely going to want to use some storing because then you're going to need to use alpha to find side A. Yeah,
So how does the ambiguous case?
we're getting there. Solving one triangle at a time. 2 minutes, maybe a minute and a half, depending on how fast you guys do your calculator work. What's A? 65.4. Okay, store that in your calculator. Store this in your calculator because now we're, so if you get, here's the deal. If you get the 74.6 degrees incorrect, then you're going to get alpha incorrect. And if alpha is incorrect, then side A is going to be incorrect. So make sure, you might want to do the keystrokes on your calculator twice. Okay? You see how that could just be a slippery slope? One mistake and it's like, whew. Use the given. The sine of 40 over 2 is equal to 65.4, which is in your calculator. Is in your calculator. What do you get? 3 point what? 3.4? Am I getting, people concur? All right, do a quick check. What do you guys call that when you check that the largest angle goes with the longest side? That's not the triangle inequality theorem. What's that called? Let's see. Okay, we'll look it up later. I'm not done. We got a triangle, agreed? What did I do wrong?
2.7.
Oh, I asked for concurrence and Kavi said, and you guys shook your head.
Yeah, wait, why?
2.7?
Yes.
Is that better?
Yes.
Well, I mean, it looks
I got two.
It looks better.
longest side.
Wait, okay. I got two.
Is it 2.8 or 2.7? You have to know how to use the store key. You're going to lose point if your rounding's off. Is it 2.7 or is it 2.8 or is it 3.4? 2.8?
It's a little off.
But see how if you don't use the store, you're going to be a little bit off and there's another half point gone. You've got your degree symbols, you didn't round properly.
It's the seven.
So how does this pertain to the ambiguous case? So first thing I started up here was it could be 74.6. That's a possible answer, but the other possible answer is 105.4. So we have to create another triangle. I just draw it. For me personally, it's just a lot easier to see. Some of you can do it without drawing it, and more power to you. Okay, so B is 40. 2, 3, and we said the other option for C would be what?
105.4.
105.4. I know, it's not a 105.4 degree angle. Can I create another triangle from here?
Yes.
Absolutely. This is the ambiguous case. 2 triangles. All right, so alpha, and you're going to store these values in your calculator.
How do we get rid of a store? Just like restore it over it?
Yeah, just store right over it. I think there's a way to do it on the calculator, like your memory. So I don't know if you know that. Yeah. All right. Yeah, Dasha.
So what does the ambiguous case come up? Like in a problem?
Angle side side in the ask case. That's how you know it's bad.
So they give it to you like that.
Yeah, you're given the ask case. What do you get for alpha? Okay, be careful with your rounding. I know I keep saying that. Be careful with your rounding. Because 105.4 was rounded. So maybe you need to go back and do the keystrokes. Okay, I know I'm a broken record. I highly recommend that you store as you go along so you don't have to redo all these keystrokes on your calculator. I didn't do it, obviously. I'm relying on you. $34.6.
Yes.
Even with the rounding? Great. Okay, so now you're going to do the sine of 40 degrees over 2 is equal to the sine of 34.6 over A. We're going to fight over those tenths, I'm sure. What'd you get?
Rounding to the nearest 10. 1.8.
1.8?
Yes.
Excellent, 1.8. Okay, so here's one triangle. Here's the other triangle. Write it off to the side. So that is purely, it makes it so much easier for me to grade. If you just have triangles, whatever, I can just look at it and move on. It's so much easier. Book, I'm going to do a couple word problems. Book 532. Several of you already have your book. Yes, ma'am.
I've been consistently getting like a very slightly different answer, but doing the same stats in rhyme and I am in degrees on my calculator.
Okay.
Do you think there's anything like wrong, or it's just me?
Do you have stored values? Are your stored values the same? Exact, the correct stored values?
Is it different if you just like you like go up and use the exact answer to store it?
No.
Because I've been-
No, you need to use the exact stored answer.
But I mean, what
Have
I've
you been
doing-
storing it?
I haven't been storing it, but I've been going like up and like left.
No,
and right.
it's not the same.
Yes, it is.
Is it?
Yeah.
All right, well then I will
Use the
look at
answer
it.
above. It may only show like 3
It does.
figures, but
It
it
has the whole thing.
stands.
Okay, I'll look at it, Catherine. I don't know off the top of my head. Or your classmates probably know a lot more about the calculator. 532, number 48. You need to draw the picture. In your homework, if you're just showing like 1 or 2 lines of algebra and getting an answer, no way. Draw the picture and label. 532, number 48. What's wrong? Are we good? It's not even that big of a picture. Like, look at number 55. Did I sign that wrong? No. I think I'm gonna have to change that. Okay, we'll see. Anyway, we're drawing.
Feeling good about that.
Chris, draw the picture. Thank you. Tom and Alice and the moon. You guys did Phoebe last year, yes? We should, instead of the moon, we should make it Phoebe. We should make it Mars and Phoebe. That'd be
Butter. Remember?
Calvin Butterball. But Phoebe, what's Phoebe's last name? Phoebe Small. You remember? I teach algebra. Oh, yeah, right. This is my 14th year teaching algebra 2 honors. I think I have the book kind of memorized almost. It's true. Someone's looking at me like, wow. I've been teaching algebra 2 honors almost as long as you've been alive.
I leaned over.
We already had
or
this conversation. No?
bent
Yes?
over. No.
It's a great course.
I leaned over.
There were some,
bent
I
over,
leaned over. There were some really good ones. There's a lot of funny puns.
and bent over.
Oh,
Eileen. Oh.
I get it. Like
Eileen.
the first name is like
Eileen.
That's
Yeah.
terrible.
Oh, they're all terrible. That's what makes them so funny. I recommend drawing a much bigger picture than I just did.
Yeah, but you're right. It's
All right. Yes? You have it drawn?
You're right.
Right. Honestly, great. So, like,
Okay. At exactly the same time, Tom and Alice measured the angle of elevation to the moon. For Tom was 49.8974 degrees, and the angle of elevation to the moon for Alice was 49.9312 degrees. See the figure. To the nearest 1,000 kilometers, how far was the moon from Earth when the measurement was obtained?
They're all
We're on Earth.
Oh.
it's flat. Yes.
Okay.
Yeah, why do it?
You know what? If you would like, we can make it round, and then we can do some like highly, intense physics calculations, which are like way above my pay grade. Yeah, no, I don't know anything about physics other than force equals mass times acceleration. That's all I know. Yeah. All right, figured it out. Word problems are by far the hardest because they're not plug and chug. And we like to just go, oh, here's the law of science, and you plug and chug, and then you can't apply it to the word problem. So we want to know how far.
But isn't the length gonna be different for like?
Well, yes. So let's figure it out. Where do you want to start? Figure out the angles? Okay, so I'm just gonna label it 1 and 2. I can't squeeze everything in there. Do we need them both? No, but we can figure them out pretty easily. So angle 1 is, I figure out angle 1. 180 minus blah blah. So about 130. So it's 130 point blah blah. What is it? 0.068 degrees. I don't know if we need both of them, but that's okay. We'll figure it out.
380.
Well, what?
Oh, nothing.
Okay. Angle 2. I could just do it myself. 180 minus 130, 0.0688 minus. Oh. 0.0338? That doesn't seem right, but.
It is. It's so far away. Well,
Interesting.
All right, now what?
we find actually far.
All right, let's find Tom to the moon.
Wait, you already know this.
Tom.
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 To the moon.
What's this question?
How about I call that 3? Tom to the moon.
That's not what they're
Got
asking.
300.
What's that?
Is that what they're asking?
Well, it's going to be interesting because they say how far was
They
the
want you to go
Earth
vertical, right?
from the measurement? Well, I don't know.
Well, you'll have to go.
I don't know.
So David says, okay, so this is a question that came up before.
I know.
Is the distance from Tom to the moon going to be the same as Alice to the moon?
No.
No. So what do we need to do instead?
Wait a minute, could be
Drop a perpendicular, yeah?
If you did count the roundness of the earth, it could be this.
Oh my lord.
That's probably what.
You're right. You're right, David.
Yeah, why?
Depending on the roundness. What'd you say, the roundness of the moon?
On the earth.
Also one that mentioned.
I didn't realize that the Earth's roundness changed. What, sorry? This is true. Are they measuring their angle
How do you
from
measure
the
the
top of the
elevation
moon?
of the moon? How do you do it? Like a little laser pointer? Like,
I would say that's roughly 49, 46.
I don't know. All right, so you drop your perpendicular, then what do you do?
Sorry.
Find the other angle. How?
180 minus
180, yeah.
minus 90.
Which one? Go ahead, Tristy. 180 minus.
49.9312 and minus 90. First one.
Minus 49.89.
I think 93 because then you drop the perpendicular and you get like
Oh, yeah, okay. So go ahead. What is it?
and minus 90.
What do you get? So essentially it's 90 minus.
Yeah, minus.
Yeah.
40.1.
Okay, I think the bell's gonna ring. I really want to get rid of your notes. All right, I have your homework packet. If you want it back.